Oh, mamma mia. Oh, mamma mia. I'm so excited. I have a very, very nice project in my mind, really. I hate spending time in front of the monitor editing my videos. It takes so much time, about 3 days for one single video, which is a crazy amount of time. I hate wasting time in this way. So I want to speed up the workflow very, very fast. And if you follow what I'm going to show you, you can adapt all the steps to your software, really. If you usually use Excel, Word, or also if you are a gamer, if you play a lot a game and you use a lot the keyboard, follow these steps. It's very easy. I don't want to use any kind of programming software, Arduino, no Raspberry Pi, nothing at all. Everything has to be analogic, completely analogic. So it's much easier also for you following step by step, and it's also easier for me just recycling things around me in my shop. So without wasting time, let's see what's in my mind. Let's start first of all taking this old keyboard. I want to hack it apart. I want to get the little circuit that is inside so that I can connect all the cables and the switches I need for this project. So let's take it apart. It's a bit hard, and inside of it I found all these rubber things. I will keep them for a future project for sure. Inside finally we see what connects all the buttons on the keyboard. There is this plastic with this graphite ink connections. It's plastic, and unfortunately I cannot solder cables to it, and the little circuit that connects to the plastic is too small, and the little processor is covered with black epoxy, so I cannot solder to it as well. Okay, unfortunately the first keyboard doesn't work, but no problem, I have more here in my shop. Theoretically, inside the keyboard, the older the keyboard is, the easier it is to hack it, because very vintage and old keyboard has inside real mechanic switches. I'm talking about real switch soldered directly to a real circuit board. So I can replace them, solder them much easier than these plastic things. So let's see if I'm lucky or not. All three of them have this rubber pad. I can use them in the shower. By the way, I'm not giving up. I want to try to connect these circuits to a USB port and see, using a jumper cable, I want to make connections directly here, randomly on the circuit board, and let's see if something appears on the screen. Yes, something is coming up, shows up, but it's very, very hard to understand the characters. For example, here the caps lock turns on. Okay, theoretically this kind of circuit can be used, but I mean it's almost impossible, because finding the combination for typing one single letter is like finding the combination of a safe. Because if I want to type, for example, the letter M, I have to find a combination between number 1 plus letter Q plus number 8, and all three together give me the letter M. And it is impossible. But my brain never stops, and right now I'm having the inspiration of integrating in this project knobs. I want to have knobs so that I can spin them and have a real effect on the software, and I already know where to get knobs. Very nice one in aluminum, so let's go. So next to the trash on the street I found these two VHS tape recorders. In all my life I dismount more than 50 of them, and I already know what to look for. I'm looking for this. This is the head that reads the tape, and is very good quality piece. Very good ball bearings. This works so good. It spins so fast. There are two ball bearings, excellent ones. And in all my life, I dismounted so many tape recorders, and I really think these are little treasure. There are so many little switches, gears, and little springs. I can use them always for my project. So if you find a tape recorder, just take it apart, no matter what. I also made a couple years ago a very fun project recycling a brushless motor from one of these tape recorders. I used a brushless motor, a very big one, like this one, and I brushed my teeth. It was so fun to make. I was all covered of toothpaste. By the way, let's be serious. I want to make a controller to control the software of the computer using this component as a knob. For example, I can grab it with my hand and I want to spin it clockwise or counterclockwise and have an effect on the software. For example, I want to zoom in or zoom out, or for example, I want to move the timeline to the right to the left or to the left to the right, just by spinning this in one direction or another. The main problem right now is let the computer understanding that this is spinning, first of all, and also the direction, the way I'm spinning it, okay? I have an idea, because this burns like a brushless motor. So if we give electricity to this component, it will start to spin because there is a motor inside. But if we spin it with the hand, this become like a dynamo, and will produce electricity because there are magnets here on the top and there are also copper windings. So if we move magnets close to copper windings, we are producing electricity. We can maybe use this electricity to give an input to the computer. The most important part is that I don't want to use Arduino or other programs or microchip or things like this. I want to make everything analogic, so it's much easier also for you to replicate the project. So let's start to see if this idea of the copper windings works or not. Let's see the animation. So let me represent what we have here. We have the keyboard. I already removed two keycaps from it, and also the electric generator. To interface the two parts together, the best solution is to use relays. Relays are like switches and they can close once we apply electricity to them. So I can bring cables directly from the keyboard to the contacts of the relay. We can do the same thing coming from the electric generator directly to the relays. So let's see if we spin the generator, what happens. For sure we are producing electricity, the electricity flows, and we are closing the relays. Unfortunately this is AC, which means the relays turns on and off very fast. Okay, we are typing characters on the keyboard. Now let's see if we are install instead bridge rectifiers. This converts AC to DC. So let's see now if we can also determine the direction where we spin the knob. So we can spin it in one direction or another, and unfortunately both relays stays on all time. So we are pressing buttons on the keyboard, but it's impossible to define the direction if we are spinning on the left or on the right. So yes, we're almost there. Okay, everything was just in my mind, maybe was a bit confused, so seeing with you schematically the electricity flowing through the cables let me really understand this cannot work. But I also understand that relays are very good for this project, so I will keep them in my mind. And right now my mind is really exploding. I'm thinking about this project night and day, and I'm also thinking about finding a solution, completely mechanical, analogic, to this problem. I also thought about placing magnets all around the knob, and these magnets can attract or repel other magnets, and these magnets can activate reed switch, which are magnetic switches. So this also doesn't work. And defining the sense of rotation of a knob like this for me is crucial, because I want to control with this knob the keyboard, and the keyboard can press keys and the keys can have actions on the software. So for example, if I'm video editing, I can spin the knob clockwise and have an effect like having zooming in the video, change the direction, zooming out the video. Or if I'm using Word, for example, and I'm typing a letter, I can move the page up or I move the page down. If I'm using Photoshop, I make the brush bigger or smaller, and now you understand what I mean. I really have an idea, so I dare you that you are smart people, let me know in the comments below what can be your solution to this problem. How can I press keys on the keyboard and define the sense of rotation just using mechanical components? No Arduino, no programming. I have a great idea and I want to show you what's in my mind. Let's move on. My plan is to use a momentary switch like this one and press it rapidly using maybe a gear like this one. I'm going to cut gear using my CNC machine, but don't worry, if you don't have a CNC machine, I put you also a PDF so that you can print it, stick it on a wood board and cut it by yourself. I suggest you also to use a file just to refine the edges of the gears. I cut here not only the gears but also two wooden bases so that I can mount all the other components. So let's take the back part of the motor, the electric generator, and you can see is a precise fit. This goes here in the middle, and I also put some glue so that never will come apart again. I'm going to use 5-minute epoxy and put 3 dots here on the wood part because I want to also fix in place the aluminum part. So I clean it up from grease coming from my hands so that I'm sure that glue dries and keeps everything very strong in place. So finally it's time to mount the gear back in place, and to do this I'm going to use 3 existing little screws. So I can take it with my hand, spin it like a knob, and the gear spins without problems. So let's take this. This is a momentary switch, has a very nice brass wheel here on top, and now it's just a matter of finding the right position where to mount it. So just be careful about the distance and be centered. You can see that every time the little wheel goes down, we press a little switch inside the black box, and we can spin it very rapidly. We have very little friction, and I love this solution. Let's take something else. This is a 3-position switch, very common one, and this will help in combination with the other switch to understand the direction where the knob is spinning. For example, if it's spinning anti-clockwise or clockwise. The switch will change position from the bottom to the center and to the top without problems. It's a good idea also to add some rubber so that we have a little bit more friction and we never lose position of the knob. To fix it in place, I can use this heat shrink tube. This is, I think, is the best solution because I don't want to use glue if in any case I have to replace it. And this heat shrink tube is very strong. You can see I can use some heat source, for example a simple flame, and it shrinks very hard and keep the rubber in place. I can already taste it with my finger and I can feel it has much more friction. Now it's just a matter of finding the right distance and the right position so that the gears engage with the rubber band, and every time I change direction you can see that also the switch change position. This will work in combination with the other momentary switch here on top to define how many times we have to press the key on the keyboard and also the direction, so which kind of key we have to press and also the action that have to make this part on the software. So yes, I love this solution. Bravo Rulof. Okay, everything is working. We have the clicker here on the bottom, and we have also the 3-position switch here on the top, and you can see it change position without problems every time. The problem now is that I'm pretty sure the rubber band will have too much friction. Now it's working, but I'm pretty sure that into a month or 2 will break off, and I don't want to dismount everything just to replace the rubber band. So I have to think another solution, maybe using springs to do this, or let's see. Okay, let's start taking some very small nails. These are like 2 centimeters long, but are very thin, and this is what we want. I can place them inside using a small hammer. You can see everything is taking shape and it spins free. Now let me take something else, a razor blade. I want to recycle the blade from it, or you can just buy this kind of blades. I put you a link on Amazon also about this component. This is made with a very nice material, it's called spring steel, which is the same material they make springs with, so it gets back in its position every time we bend it. I want to place it inside a little wood block. Be very careful when you handle razor blades because are very sharp. Don't cut your fingers. So you can see it went inside the wood. It can bend, but is secure inside. I want to cut the part using some scissors so it's thinner. I make a hole here in the center of the wood base. A long screw will be placed inside so that I can fix it here on the wood base of the aluminum block itself. So you can see now that everything works. The little nails catch with the razor blade, and every time I change direction, the little nail catch the razor blade and bring it in the opposite direction. So we made almost the same work, the 3-position switch I showed you earlier, but this time we have very less friction because the metal blade is in metal and also the nail, so it just slips and skid on top. So let me take 2 magnets, and I made a plexiglass L base. This will be mounted here on the side of the razor blade. This will be an electric connection. Later I will explain you better how it works. Now it's just a matter of finding the right position and the distance so that the razor blade can catch with the nails and also have connection with the magnets. So you see that every time I change direction, the razor blade goes in the opposite direction. So now it's just a matter of placing the same plexiglass base also on the other part. So finally this is the part almost completed, and you see the razor blade catch with one magnet or another. I like to call this a switch or maybe just an exchanger, so we can change position every time. So you can see now the difference between the new prototype and the older one. The new one has almost no friction and the older one has a lot of it. So I can connect copper cables directly to the screws and also to the razor blade, and the plan is to bring electricity to the center cable, like the orange one, so that the razor blade can change electricity and give electricity to the pink cable or to the yellow one, depending on the direction of the little nails. So now it's time to take 2 relays and something to power the relays, so a transformer can be enough to do this. So let's see what we have here. We have the keyboard and we have also the knob we just made. We need also to interface the parts together using some relay and also a power source. The relay are like switches that are activated once we apply electricity to them. So let's see how to connect everything. Bring cables from the keyboard directly to the contacts of the relay and the power directly to the relays. Also the cable goes here coming from the knob. Let's see what happens if we start to spin the knob. The razor blade moves and goes on the right, which means we are giving power to the relay. Nothing happens until we press also the little switch that is here on the bottom. Every time it gets pressed, we are giving an impulse which closes the relay, so we can press the character on the keyboard. The interesting part happens once we change direction of the knob. If we spin it counterclockwise, we are closing the other relay, the top one. You can see that we are pressing then the character on the keyboard. So depending on which direction we spin the knob, depends also the character that is pressed on the keyboard. So we can have different effects on the software. So this is a very clever and simple way to make analogic something so complicated, and you can see it works even if we change direction very fast. Yeah, Mamma Mia, I'm really so happy today. I'm so proud. I made by myself a mechanical knob that doesn't require software or programming to let the keyboard and the software do things. Okay, I'm so happy today, really. We just have to connect other parts, so let's see how electrically connect everything we need. We need also buttons and other things, so let's move on. I made another gear like this because I want to have 2 knobs to control in some occasion directly with 2 hands so that I can speed up the workflow. Let me take a picture now because I want to make the keyboard itself. So I can import the picture into Fusion 360, and after calibrating the picture using the centimeter I took a picture of, I'm sure that my hand has real size. I can then place all the position of the switches I need for this project and also the position of the 2 knobs, one on the right and one on the left. I cut holes for them, and I also decided to put my logo and the logo of Premiere, which is the software I use to edit videos. I resized an old wood board, secure it into my CNC, and the CNC took only 10 minutes to cut all the holes I need. You can see the holes are very clean, and I have to just make a wood frame big enough so that the control panel, this one, fits inside. Let me take these very nice buttons, have a very nice clicking feeling, and also have light inside so I can use them in the night. These are usually installed into vintage arcade console. I can secure the buttons using a plastic nut and also install the switch with the light. Different colors for different application. It's time finally to fix in place also the aluminum knobs. You can see everything fixed perfectly, and I can secure them from the back using some wood glue or maybe some screws. Now let me take something else. I'm talking about the most important part of this project, and I'm talking about a PCB. This comes directly from Amazon, has an USB port, and all these holes are pre-soldered, so it's much easier to solder cables directly to it. Not like the stupid circuit we found on the old keyboard. I installed all the switches on the back, and now it's time to take only 4 relays that are the only components missing for this project. So I can then take copper cables and connect them following the instruction of the keyboard and the schematic I showed you earlier. So let's see what happens once we change direction and what happens every time the clicker clicks. You can see that changing direction also change the relay that is activated. So the schematic I showed you earlier works for real. Now I printed with my computer printer all these little labels, and it's just a matter of place them inside the cover of each button. For example, this is play and stop.
Okay, finally here we are. I have my laptop. It's running a software, is a keyboard tester. I mean, this is very useful because, for example, if I press a key on the keyboard, it recognizes the keys. So let's see if via USB I've connected properly all the buttons and also the knobs we just made. So theoretically, if I press, for example, the play and stop button, I should press the space bar. And it works. Let's see also if all the other buttons are connected properly. I will say yes, I can save, I can cut, I can select. And later we will see also the knobs, but let me talk about the important buttons are the 2 yellow and the red one, and also this one are multiple actions switches. This circuit board let you pre-save actions. For example, if I want to press with only one button, Ctrl plus C or Ctrl plus Z to delay it, come back, or paste, it's very simple. I just have to press one single button and you should see appear multiple actions here on the software. You will see for Ctrl V for paste. It's very rapid, it's very fast. I don't know if you can understand it's pressing, and also for paste and cut and go back, Ctrl Z. So this is working, but the best part is to see if the knobs are working. So let's see if I'm spinning this clockwise, what happened. It should turn on a number. Yes, it's turning on very rapidly the number 4. And if I change direction, it should change also the number. So clockwise, counterclockwise. It's pressing now very rapidly the number 3. If I change direction, number 4, number 3, number 4, number 3. And this is how it works. The same thing works with the other knob, so I can press rapidly the number or the other. So it really works, and I'm very happy about this solution. So let's see in the software how they behave. I usually edit my videos with Premiere. I have it here, so I can open Premiere. Let's see, for example, this part. This was the video about the headphones. So let's see what happens. Maybe it's time to zoom in the video so you understand better what's happening. For example, let's see what happens if I spin this knob clockwise. It will move the frame, move forward frame by frame. And if I want to change direction, I go back this way. This is very useful if you want to cut precisely the clip. So you can see I move forward and I move backwards, no problem. And I can decide just the right moment where to cut the video right there. So very, very easy. The same thing can be done with the other knob, but we have a different effect. This time we are going to zoom the video and zoom out the video. So I can select, for example, the timeline, which is this part of the project, and you can see that moving the knob here have an effect here. You can see I'm zooming in the video, the timeline, and I'm zooming out and zooming in. So you see everything is working. I will use this panel to edit my videos, but this doesn't mean you cannot take inspiration and adapt it to your needs. For example, if you are a 3D designer, you can design faster by changing view and zooming in the project. Assign all the switches to your needs, and this depends only on the software you really want. This is very simple. You can go in the software and assign each letter of the keyboard to a function. It's very easy, and then you connect the same function to the keyboard here inside. Talking about the keyboard, yeah, you find links about all the parts I use for this project here below on Amazon, so check it out. You find also the PDF and also the 3D file of the knobs inside, so you can 3D print them by your own. So you find everything. At this point, I only ask you something. I don't know why the algorithm of YouTube is kicking me out. My videos doesn't get so much attention, so if you think that this video deserves a like, just leave a like. This is very appreciated. I leave you here next to me the two previous videos, so surround headphones, real surround headphones that help me win every game, and also the previous videos. So check them out. See you next week with another do-it-yourself tutorial. Ciao, ciao!